This animation will show why we observe apparent retrograde motion for Mars. The lower window will show the orbits of Earth and Mars, with the names of the zodiac constellations that we see in the distance at each point. The upper window will show our view from Earth, in which Mars appears to move among those zodiac constellations. As you watch, keep in mind that the animation is simulating a full year each time you see Earth orbit the Sun. In other words, the changes you see in the view from Earth are something you would notice only if you marked Mars's position in the sky night after night for many months. On a single night, Mars rises in the east and sets in the west, just like all other celestial objects. We start by watching a few months of simulated motion in which we see both Mars and the Sun moving eastward relative to the stars in our sky. As we pause, notice that while the animation showed the Sun passing directly in front of Mars, in reality, Mars would generally be slightly above or below the Sun in our sky, and would be hidden from view at that time because it would be obscured by daylight. We now resume the animation. Although it is going fast, you should notice the following key points. In the upper window, you can see that while Mars usually moves eastward relative to the stars, there are times during which it appears to turn around and go backward, or westward. The word retrograde means backward, so those periods represent what we call apparent retrograde motion. In the lower window, of course, you'll see that both Earth and Mars always orbit the Sun in the same direction, with Earth orbiting faster. If you watch closely, or stop and start the video, you'll see that the periods of apparent retrograde motion occur as Earth passes by Mars in its orbit, which happens about once every 2 years.